Hello everyone. Uh, with me, I have a physics question. It's about steering effects of forces, also known as moments. Alright, this question is coming from June 2002 Cambridge, paper 2, question 6. Alright, so this is the question and it reads, figure below shows a crane lifting some bricks during the building of a house. Right, so this is the crane. There's a counterweight here, the arm, and the bricks are being loaded here. Alright, so the weight of the bricks produces a turning effect or moment on the arm of the crane about the point P. So we have P here. Right, weight of the bricks is 12,000 newtons. Right, calculate the moment of this force using the distance on the figure. So I've been given 20 meters from P to the point of action of force, right? Then B asks us to explain why the counterweight is necessary. This thing, why is it necessary, right? So that gives you a mark. Then secondly, B asks us to suggest one advantage of being able to move the counterweight along the arm. So this one is not fixed. You can easily move this one here, right? Then the other one is C. Calculate the useful work done by the crane in lifting 12 newtons, 12 kilonewtons load to a height of 15 meters. Right, let's start. Alright, so start with the first one. So let me see a solution. Okay. So turning effect of a force with that distance. So we know that moment is force times perpendicular distance, right? Perpendicular distance. Right? So this is the perpendicular distance. You can see that it's making an angle of 90 degrees here. Alright? So this one times the force there. So this is going to be 20 meters by 4,000 newtons, right? So that's, when we multiply, what are we going to get? 12 times 2, that's 24, right? And Newton meter, right? So Newton meter. So that's the answer. Okay? Let's go to question number B. Okay? Explain why the counterweight is necessary. Okay? So think about it. Okay? So this thing here is necessary because it keeps the arm in equilibrium by providing the opposing moment. Alright? So we're going to say keeps the arm in equilibrium by providing the opposing moments. What does that mean? It means the moments produced this side are supposed to be equal to the moments produced this side for the principle of moments to be obeyed, right? So if we have a moment of say 240,000 newtons, so also this one is producing the same opposing moments for this arm to be in equilibrium, right? Then number 2, suggest one advantage of being able to move the counterweight along the arm. So one advantage is that we are going to avoid toppling of the arm. Alright? Number 2, you discover that even when you're changing the load here, the size of the load, right? Minus changing the weight of the counter the counterweight, we can easily change the distance here to balance up the change in the load here, right? So that's 2. Then coming to question C, right? See how is it going to be? So we said 2 here, we said to avoid arm from toppling over, that's 2, that's 1. Then 2, I can say to be able to carry different sizes of loads. Okay? Be able to carry different sizes of loads by simply moving the counter weight along the arm. Right. Is that clear? So let's solve the last one. The last one here says, calculate the useful work done by the crane in lifting the 12,000 Newton load through a height of 15 meters. We know that work done, right? Done is equal to force, the amount of force times the distance moved, right? Distance moved, right? So the distance moved, they're saying it's what? Lifting the 12,000 loads through a height of 15 meters. So distance moved there is 15 meters, right? So here, work done is different from moments in the sense that moments, it's the force times the perpendicular distance. Work done is a force times the distance moved by the force, all right? So this is going to be 12,000 newtons, which is the force here is maintained, multiplied by 15 meters, all right? So that this is going to be what? When you multiply here, you get something like 180,000 Newton meter. Okay? Now we know that work done can be expressed as a... Okay, so the last part there, we have 180,000 joules, all right? We express work done in joules, right, to differentiate it from moments, that is in Newton meter. Thank you.